all, welcome to another LeetCode problem. Today we are going to solve problem number 238, product of array except self. So this is quite interesting problem. So if I read the problem description, so what is given is uh, you are given an array of numbers and return the array of answers such that a of I is equal to the product of all the element of num except nums of I. So basically what is given here is you are given a nums of array here, and then you have to return this array, which is nothing but product of. So how you have to calculate this particular array? Basically you have to read this, you have to get the product of all the elements of nums of I except nums of I. So we will get into the details of how we can solve this problem, but we have to keep in mind that we don't need to use the division operator here, and then also we have to solve the problem in O of n time, right? And then it is a guarantee that the product will be always a 32-bit integer, right? So let's understand the problem. So if I have to solve this problem in a brute force way, right, then it is the most simplest way is I can have is like, okay, I know that this is my input array, and then when I'm calculating the first position here, so I want to multiply all the element remain except this element. So let's say for first position, so I want to multiply 2 into 2 into 3 into 4, that is going to be 24, and place it at the first position. And then when my I pointer is here, then I want to multiply 1 into 3 into 4, so that is going to be 12. And when I'm at this position, then I want to multiply 4 into 2, that is going to be 8. And then same way when I'm at the last position, then I want to multiply all the element on the left hand side, that is 3 into 2 is 6 and 6 into 1 is 6 again, so that will be here, right? So one of the simplest approach will be, okay, maybe I can use two for loops. First for loop, which will be basically, let's say I is going to be pointing here, and then j, let's say j will go and multiply all the elements and then bring the result here. And then next again when I moves here, j will again take this element and then these two elements and then move the result here. But the given in the problem it is given that we cannot use two for loops, because if I use I and j, that will be O of n square complexity, and we don't want O of n square complexity. What we need is O of n complexity, right? So definitely we cannot use two for loops. Right? Now second thing we can do is, okay, if we cannot use two for loop, what I can do is I can multiply all the elements, that is, let's say 4 into 3 12, 12 into 2 is 24, and 24 into 1 is 24. So I can multiply all the volume, and once I got the product of all the elements, I can go ahead and simply divide. So let's say I came here, 24 divided by 1, that is again 24, 24 divided by 2, that is going to be 12, and then 24 divided by 3, that is going to be 8, and then 24 divided by 4, that is going to be 6, right? But again in the problem statement we are given that we don't need to use division operators. So definitely, even though if I take product of all the elements, I cannot solve this problem with the division operation. And also if we have like 0 or some element, then it will be uh, mathematical error, right? Division by 0 error you will get. So what is the so then how we can solve this problem? So in order to solve this problem, what I need is, right, so let's say I'm at this position, at position number 3. So in order to solve this problem, I need to know the product of all the elements in the left and then product of all the elements in the right. And then if I multiply the left product with the right product, I'll get the result, correct? So what we can do is I can calculate two array. So first array will be like forward array, and the second will be my backward array. So first forward array, what will contain is product of from the right to, so on the left to right, and then backward array will contain product from right to left. So let's look at the forward array first. So if I just hide this and then just keep the focus on the forward array. So initially I am at the first position, and let's say I take another variable, let's say forward, that just to maintain the multiplication numbers. So I'm at the first position. So if I multiply 1 into my forward first position element, that is going to be 1. Now I update my forward into, that is 1 into 1 also 1. Now next, if I go here, so I'll multiply this second number, that is nums in I, 2 into the forward element. So that is going to be 2 again. That comes here. Now when it comes to third position, so I'll multiply 3 into forward element, that is going to be 6. And then I'll store here. Now I came here and then I see 4. So I multiply 4 into forward element, that is going to be here. So basically, as soon as I'm moving from left to right, I'm multiplying each element and then I'm storing into the forward array. This is one array, another array. Now next, same thing I can do with the backward array. So I can have backward variable and then I keep multiplying. So initially I start with the 4, and then when I'm moving here, so I start 4 into 3 is 12, and again 12 into 2 is 24, and 24, this number into 1 is 24 again. So I got forward array and I got backward array. So that contains a multiplication from left to right and then from right to left. Now I need to calculate the final list or array which will hold the result, right? So let's say I'm at this position, right, the number 3. Now I need to know the multiplication, all the product of all the elements in the left hand side for the number 3, and all the element in the right hand side, product of all the element on the from the right hand side. So I can look at the left arrays. Okay, product is 2, and for this 3, I'll look at the right array, which is 4. So I'll multiply this into this, that is going to be 4 into 2 is 8. There'll be some corner cases. So let's say I'm at this position, so there is nothing on the left hand side, so only what I have is the right hand side. So I'll just take this numbers and then I put it into the result. Same way, when I'm at this position, there is nothing on the right hand side but everything on the left hand side. So I'll just take these numbers and I put it in the array, right? So basically here, this one, and then in this case, this will this one, correct? Okay. So in this case, the problem is you have to take two arrays. So first is your forward array that contains a multiplication from left to right, and then you have backward array that contains a multiplication from left to right, right to left, and then finally you have to have the resultant array where you'll have the multiplication from all the elements except the nums of I, the ith position element, right? But we can solve this problem in a better way without using the forward array and the backward array. We can just have the final result, which is the final array, and that will show the results. So in the example, the question, if you read, it is given that can you solve this with O of 1 space, and then O of 1 space does not consider the resultant array. But in this case, let's say if I take forward array and then backward array, that will be O of n space, right? But without using these two arrays, can I solve this problem? And the resultant array is not considered as part of O of n space. So if I don't use forward array and backward array, if I just use resultant array, that will be O of n's 1 space complexity, right? So we can solve this problem. How we can solve it? Let's look at the problem. So if I now, let's think of, I don't have forward array and backward array. I just have initial nums of array, nums of element, which is 1 2 3 4, and then I just have resultant array where I'm storing the result. So in this resultant array, what I'm going to store is the first time I'll store the forward multiplication. So 1 into 1 will come here directly, and then 2 into 1 is 2, and then 3 into 2, this number is 6, and then 4 into 6 number is 4. So I stored the forward multiplication, correct? Multiplication, correct? So I store the forward multiplication. Now this I'll update same array for the backward multiplication. This position, the last element. So I'll start traversing this particular list. Since initially I traverse from left to right to get the multiplication from left to right. Now I'll start traversing from the right to left, right? But I'll start not from the last position, I'll start from the this position, correct? So now this position, I know this is nothing but the multiplication of all the elements on the left hand side. So I can straight away take this element and update my array and then remove 24 and put it here. So my this will become is, so this array I'll remove 24 at the last position and update is here. At this moment I'm going to maintain a backward array. Backward array basically we start with one variable, just another variable that will basically hold the multiplication as soon as I go towards the left hand side, towards the first version. And then the backward, when I'm storing this here, so I'll multiply this backward with the 4 element, so that I know that this side I have only 4 as an element, but this side could be there could be other numbers. Now I stored it here. Now my pointer moves here, right? So when for this position, what I need to do is, I know the left hand side everything is multiplied by 2, everything, all the product is 2, and then this side I use backward, which is going to be basically 4. Now I use 4 here. So 4 is 4 into multiplied by 2 is 8. Now I move to the next position here. So my array will be pointing here. So when my array is pointing here, I am updating the basically next element, because I am starting from here. I am not starting from the last position. So when my initially array was pointing here, I was pointing here, I was actually updating the last position. So I plus 1 position. So now array moved here, so I updated this position. So 6 and 8 are updated. Now left element is this one. So array is pointing here, I is pointing here, but I want to update this one position. And meanwhile my backward is also getting updated, right? So 4, initially it was 4, now I have next element is 3. So 1 into 4 into 3, that is 12. So 12 into 1 is 1 again, because left hand side multiplication is 1, right hand side multiplication is 12, so that will be 12. So basically nums of I, so result of I multiplied by backward element, backward variable, so that will be updated here. Now I have nothing to move here. So as soon as my array traversal is finished, so 0th position element I'll just take backward result 12 and then I'll multiply by 2. That will be updated by 0th position, and that's it. You don't need to, only for the last position, when you came as the last position, that time 0th position you just have to update with the backward result. So that will fill the last portion, and that's it, because now you're using only one array with some extra variables here backward, and that's it. You're not using extra forward or backward array that I shown here in the example, and that's it. That's the logic here. I mean, hope you understand. So if I look at the code, is quite simple. It's few lines of code actually, but the logic is important to understand, how we can use the backward and forward information to multiply the element. So if I go back to the code, so I'm initializing my result variable, that is just all the elements are basically 1 1 1. So this will just contain 1 comma 1, sorry, 1 comma 1 comma 1. So all the element, so that I can store the, if I store 0, then multiplication could become 0. So that's why I'm using 1 here. Now I'm calculating forward array. So forward array is basically this array 1 2 6 4. Now result is basically my this element, right? In this one I am going to update the resultant array, which will store the forward multiplication 1 2 6 4. So after this multiplication is done, resultant will hold the 1 2 6 4 as a result. So that is going to be here. It will be 1 comma 2 comma 6 comma, sorry, what is it, 24, I think. 1 2 6 24. Now once I got my resultant array with the forward multiplication, I'll start with the backward multiplication, but I'll start with the -2 portion, that is this portion here, so that I can update the last portion. So I plus 1 always update the I plus 1. So this will straight away go to the last portion. So if I see here, the resultant I plus 1 is getting updated with the backward into result of I. So backward is 1 initially, so result of I is basically 6 first time. So it is 6. So 6 into 1 is going to be always 6. Now I have updated my backward to keep the track of right hand side element multiplication. So backward is going to be 1 into 6. That is nums of I. So backward is 1 and nums of I this particular element. So 4 into 1 is, that is going to be 4. So I updated my backward, and the same I keep doing this. As soon as I reach the last portion, the first portion of the array, I'll just update the backward result. That is, as soon as I reach here, right? So backward will become 24. So I'll just update the result of 0 will be 24, and that's it. So if I just run this one, so this is fine, and then you can just go ahead and submit. So not too bad, 93% efficient. Uh, Hope you understand the logic here, and hope you like the video. Thank you for watching. See you in the next video.